Hello, my name is Santiago Martinez, and today we're going to be going over problem 6 of exam 1. We are given the graph f of x is equal root x, and we want to turn it into a simple function of g of x is equal to 3f minus x plus 2 plus 1. So this is incredibly important because we're going to be analyzing how to actually do this. So we are first going to notate that our parent function is a root graph, and we're going to apply that to our function. First, we have shift left units. Shift left to right always comes first, and we get the 2 from the plus 2. So it's going to be a negative 2 because it's inside the parentheses. Then we have flip across the y-axis, which we get from the negative x the negative inside the x. We get a vertical stretch factor by 3 because the 3 is in front of the f, which is going to be in front of the function. So 3f. And then a vertical shift up from the plus 1. This one we do get to keep the same side as the back there. And keep in mind that we always start with a shift and a vertical shift lastly. So a shift left to right or vertical shift left. After you see that I already marked my graph here, so I'll go over it with you. We always mark our OG graph, right? So our OG graph has 0, 0, 1, 1, and then 2, 8 is our regular root graph. So it's important to notate that. And what I like to do is work through each step in my head. So whether that's vertical shifting or not, I like to always start with my origin point and work through with my pencil. So always we're going to shift left. You can see in the video I miscorrectly do this. I actually shift up first, but then I notate that I did it wrong. So I shift left 2 units. So 1, 2. We're actually going to be on negative 2. And our origin, and then after that all our points shift too. So our 1, 1 shift, and then our 2, 8 shift. And then it's important to note that we're going to flip across the y-axis. And you see me correct my mistake here. So I can't quite get rid of that just yet. Let's see. Shift 1 and shift 2. So our origin shifts, and then we do our flip across the y-axis. So remember, all our points just flip across the big y-axis, and we're actually end up going to be going the opposite direction, as you can see in our final graph. So I notate flip over the y-axis, and our overall graph changes its course and direction. If we take a peek at the next step after we get done notating, we are going to do our factor. Stretch factor by 3, so we're going to multiply each point by 3, and only the factor that's affecting. So we have a vertical stretch, so it's going to affect our vertical values. So you multiply each value by 3 and see what we get. So right off the bat, you can see how that affects that. We're going to have 2, 1, because then we're going to have 2, 1, 3, and then negative 2, 7. And I kind of annotate that more here. So x gets multiplied by 3. Or excuse me, we just multiply by 3. So right, so our y values all extend, right? So we have a 3 and a negative 7 for our next point. And then there will be another value at 9, or at 10, excuse me, after the multiplication is done. And the last part of the graph is obviously to shift, which will shift up 1. And these values look a little distorted, but after we shifted, that's when we multiply our y value by 3, because it's a vertical stretch. So just keep that in mind. That's why they don't seem multiplied by 3 right away from our original graph, because there was a shift involved. So that's why. And I notate that a little bit here as well. And it's important to note that we still have our shift. I haven't notated it yet, but we will shift up 1, which will also again change our y value. So it's not going to be cut and dry, right? It's not going to be 7 is 7, because there's nothing multiplied by that can give you 3, right? There's no factor of that. So thank you so much.